Word on the street is that today we are going to learn about solving systems of linear equations by substitution.
Yes, and we are going to keep it simple. We will talk about two equations and two unknowns. We could have many equations and many unknowns. It can get wild and crazy.
Calm down.
To solve the system of these two equations, we need to find values of x and y that when substituted back into the equation will make the equations equal. That is, each equation will have the left-hand side and the right-hand side match up.
This sounds very familiar. We did that with one equation and one unknown.
Exactly. Now, in the process of going through the substitution, some odd things might happen.
Ghosts will come into the room.
Yes, the ghosts of past mathematicians.
Funny.
There will be three possible situations. In one situation, after we go through all of the work, we will find out that something odd has happened.
What?
The variables have fallen out and the numbers we are left with do not equal each other.
Will I have made a mistake?
No, you have not necessarily made a mistake, so calm down. What has happened is that the two equations represent two lines that are parallel.
Maybe the slopes were the same.
They definitely were the same. Good job. Another odd thing might happen.
Do tell.
When substituting, the variables fall out and the numbers end up to be the same on either side of the equal sign.
Wow.
In this situation, the two lines are actually one line.
Yes, this does sound similar.
Oh yes. We talked about these situations before. So do not worry.
Cool.
Now, getting back to the process. We take a good look at the two equations. I like to label them 1 and 2 so I do not get confused.
I will try that. What are we looking for?
We are about to solve two equations. It is similar to one equation in that we simply want to find values for x and y that satisfy the equation. But in this case, both x and y have to satisfy both equations.
I can deal.
This is the part that many people do not recognize. These equations are lines, right?
Yes.
Now, in order for both x and y to satisfy both equations, the two lines must cross. They must cross at the same point. The same x and y coordinates.
No way.
Way.
I had no idea.
Well, spread the word. Tell your parents. Tell your friends.
Calm down.
So let's go. We simply solve one equation for y. Pick either equation 1 or 2. The one that looks the easiest to isolate y is the one I choose. Say it is equation 1.
Okay.
After we solve for y, we take the entire side of the number 1 equation, the side with the x in it, and plug it into equation 2 for the y term. It is as simple as that. Replay this last sentence.
And then we isolate the x?
Exactly. Once we have isolated the x, we plug that value into the first equation and we have our value for y. We can check it by plugging in where we have not plugged in.
Easy. I am going to rock at this.
Word. Good luck in your math. I believe in you.